In this presentation, we're going to look at some basic probabilities. So suppose A and B are events from a sample space such that probability of A is 0.65, probability of B 0.45, and the probability of A intersection B is 0.32. Just as a remark, that is the intersection symbol. Let's try that again. Intersection. And we're asked for a couple of things here. The complement of A, complement of B, probability of B given A, probability of A union B. So that symbol there is union, and then the complement of A union the complement of B. That's a tricky one. We'll try that out later. So let's start off with the first one here. Probability of the complement of B. Probability of the complement of B is simply 1 minus the probability of B, and that is equal to 1 minus 0.45, and that is equal to 0.55. Okay, so that's the first one. So the second one we'll have a look at now. Probability of B given A. Now this is, I'll do this one here in black, this is the conditional probability. And we might verbalize that as probability of B given A. Now, in the back of the exam paper, there is usually a formula given. So I'm just going to put the formula from the back of the exam paper here. And it's quite important. So this is the conditional probability formula here. And it looks like this. So it actually would be given using in this format here. A given B, probability of A given B, that's equal to the probability of A intersection B divided by the probability of B. Now, just as a remark, actually, you might notice that whatever is on the right-hand side of the bar there should correspond with whatever is underneath the fraction on the other side of the equation. Okay? So that's just a certain important thing to pick up on. Just as another remark, we have A union A intersection B, probability of A intersection B. That can be written as probability of B intersection A. They're exactly the same thing. It's just taken from the point of view of the other variable or the other event, probability of B intersection A. So that's an important thing there to remember. So we're going to use that formula there now. We're actually interested in probability of B given A. So what we're going to do is just swap around the A's and B's. We're going to sort of put B's where A's are, and the A's where the B's are. So the probability of B given A can be written like this: probability of B intersection A divided by the probability of A. Okay, and just as a remark, again, just to re-emphasize it, this is the probability of B intersection A. So it's a straightforward enough calculation now. Probability of B given A equals 0.32 divided by 0.65, and that's more or less 0.49. It's just slightly less than 50%, and just rounded to 2 decimal places. So that's probability of B given A. So we're on to the third one now. And the third one here is A union B. Now this is a straightforward enough calculation. This is using a thing called the addition rule. Okay. And the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersection B. Okay. So that is equal to 0.65 plus 0.45 minus 0.32, and that works out to be a bit of calculator work. After a bit of calculator work, that is equal to 0.78. Now, just as a remark, I haven't really used Venn diagrams in this solution yet, but they are handy to sort of visualize what we are doing. So suppose this is a very rudimentary Venn diagram here. And we have, this is A, this is B, and this region here between the two circles corresponds to A intersection B. It's essentially to stop A intersection B getting counted twice. It's part of A, it's part of B. So up to here, it gets double counted. So we just have to subtract the probability of A intersection B just to stop it getting double counted. So the answer there to the second one there, or the third one there, is 0.78, and again the second one was 0.49. Okay. So the last one. Now the last one actually is one where we would use Venn diagrams, because they can get tricky. So Venn diagrams are very useful for trying to figure out what exactly is going on. So what I'm going to do here is actually draw A intersection, or I'm going to draw the Venn diagram of the complement of A, and then separately the Venn diagram of the complement of B. So this is the complement of A. So we have A and B, and this is the complement of A. It's everything outside that circle. So it'll be like this here. So it's everything in the shaded area, including B. Okay. So it's everything outside this the blue circle for A, and with B being here. B is the same thing, but just taken from the point of view of B. So it looks like this. So we have A there, and then we have B there, and it looks like this. Let's put it in here like this. That's it there. Now, what we're interested in is the union of A and B, and it is a let's just put some white there. It is like just a bit more. That's just annoying me there. There we go. So that is exactly, those are the Venn diagrams for A and B, and what we're interested in is the union of these two. So what we're interested in are regions that are either shaded yellow here, or shaded in here, or shaded in here, or both. That is the union of A, and that is the union of the complement of A and the complement of B. So what we're going to do here is just you might notice that we can sort of split up the Venn diagram into 4 regions, and I'll just talk about each region in turn. Okay. So the first region is everything outside the 2 circles, and is it shaded in at least one of the diagrams? Yes, it's shaded in here. I'll just put a little dot here to just emphasize it's shaded in here, and it's also shaded in here. Okay, so that's going to be part of our shaded region. Now B is shaded in this one, so we're going to shade that one in. A is shaded in this one, or A only, this region here. Sorry, I should be a bit clear about this. This region is shaded in. This region here, so that's why that gets shaded in. Now, this region here is shaded in. 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 So they're all going to get shaded in. Okay. Now, which region is not shaded in either of the two? In either of these two, which region is not shaded in? And it's actually the intersection area. So that's the only region that does not get shaded in. Okay. So essentially what we getting at here is this here, probability of the complement of A union complement of B. That is the complement of A and the A intersection B. Is what we're looking at, is what we're saying here. It's there are the complements of each other. The A intersection B is the only part of the Venn diagram not described by this expression here. So the answer is 1 minus, so it's 1 minus, what we're interested in is 0.32. So the answer is, let's do it on the next slide here. Probability of A, complement of A, union the complement of B is 1 minus the probability of A intersection B, and that is 1 minus 0.32, and the answer to that is 0.68. Okay, so actually, just as another way we can sort of express this, we can also express it as the complement of the probability of A intersection B. Okay. Just as a remark, you might actually notice that this here, this expression here, you might notice this for later on. That is actually known as one of the De Morgan's laws. If you're going to do set theory or anything like that in the future, it's actually De Morgan's laws is what that is actually called. It's not actually part of the course, but it's actually not. It's very simple to work out. Okay, 0.68 is the answer to the last one anyway. All right, that ends this presentation.